Hello students, welcome all of you. In this video, we will discuss two very important examples or problems based on canonical transformation. First example or problem is to show that capital P equals to 1 by 2 under bracket P square, a small p square plus a small q square, bracket closed, and capital Q is equal to tan inverse a small q upon a small p is canonical. And second example or problem based on canonical transformation is to show that the transformation capital Q equals to log under bracket 1 by a small q into sine capital P bracket closed and capital P is equal to a small q cot a small p is canonical. First of all, we will solve the first example or problem of canonical transformation, that is to show that capital P equals to 1 by 2 under bracket p square small p square plus a small q square bracket closed and capital Q equals to tan inverse a small q upon a small p is canonical, where a small p and a small q are momentum and position coordinates in the old system, that is old coordinate system, while capital P and capital Q are the momentum and position coordinates in new coordinates system respectively. कैपिटल P न्यू कोऑर्डिनेट सिस्टम में मोमेंटम है एंड कैपिटल Q न्यू कोऑर्डिनेट सिस्टम में पोजीशन कोऑर्डिनेट है, जबकि स्मॉल p ओल्ड कोऑर्डिनेट सिस्टम में मोमेंटम है एंड स्मॉल q ओल्ड कोऑर्डिनेट सिस्टम में पोजीशन है. Now to solve it, that is solve this example or problem, we have to show that the product of a small p multiplied by dq, d small q, minus capital P multiplied by d small d capital Q, that is dq, must be an exact differential. Then the given transformation capital P is equal to 1 by 2 under bracket a small p square plus q square and capital Q equals to tan inverse q by p will be canonical. So we have to show that the product of a small p into into dq, that is d small q, minus capital P multiplied by d capital Q must be an exact differential. So write down product of a small p multiplied by d a small q, that is dq, differential of position coordinate a small q in the old coordinate system, minus product of capital P, that is momentum in the new coordinate system, multiplied by differential of position coordinate in the new coordinate system, that is dq, d capital Q, and it is equals to p into dq minus capital P is given 1 by 2 under bracket p square plus q square, so it is 1 by 2 p square small p square plus q square multiplied by dq, that is d of tan inverse q upon p, a small q upon a small p. Q is given, that is position coordinate in position in new coordinate system is given, capital Q is equal to tan inverse a small q upon a small p. So d of capital Q means d of, that is differential of the given position coordinate in new system is tan inverse. In place of q we can write tan inverse tan inverse q, a small q upon a small p. Now it is p a small p multiplied by d a small q minus 1 by 2 into p square plus q square multiplied by, now differential of tan inverse q by p using the formula of uh, d by dx of tan inverse x is equal to 1 plus 1 upon 1 plus x square, or d of tan inverse x is 1 upon 1 plus x square into dx. So differential of tan inverse q upon p is 1 upon 1 plus x square. In place of x there is a small q upon a small p, so 1 upon 1 plus q upon p the whole square, that is q square plus q square upon p square, and then d of multiplied by d of, now differential of d of tan inverse q by p is 1 upon 1 plus q by p का q upon p to the whole square, that is q square upon p square, and now multiplied by now d of q by p, so it is d of q by p. tan inverse q by p का हो गया 1 का डिफरेंशिएशन 1 upon 1 plus q by p square, and now differential of q upon p. So it is now p into dq minus 1 by 2 under bracket p square plus q square multiplied by 1 upon, now LCM is p square, so it is p square plus q square upon p square multiplied by d of q by p. Now it is in the quotient form, so we have denominator square, differential coefficient of q by p is, now denominator is a small p, so it is p square, now it is in the numerator, it is denominator is constant, so p multiplied by dc of numerator, so numerator is a small q, so it is dq minus minus numerator, that is q, multiplied by dc of denominator, that is q dp. Now p square in the denominator of p square plus q square upon p square will cancel out to p square, so we will left with, now we have p into dq, that is p into dq minus capital P into capital dq is p into dq minus now p square and p square in the second term will also cancel out, so we will, so we have 1 by 2 p 1 by 2 p dq minus q dp only. So we have p, a small p into dq minus capital P into capital dq equals to a small p into dq, d a small q minus 1 by 2 under bracket p dq minus q dp. Now we can write it as p dq minus 1 by 2 p dq, and next term is minus 1 by 2 multiplied by minus q dp is plus 1 by 2 q dp, and p dq minus half p dq is 1 by 2 p dq. P dq minus half p dq is half, it is only 1 by 2 p dq, and next term is, second term is 1 by 2 q dp, and it is differential of, now it is differential of p into dq, 1 by 2 is common, so it is 1 by 2 p dq plus q dp, and therefore p dq, a small p multiplied by dq, d a small q minus capital P multiplied by d capital Q equals to 1 by 2 differential of p into differential of p into dq plus q into dp, that is differential of product of p and q. So it is differential of product of p multiplied by Q, and now it is a, now we can write it as d of 1 by 2 PQ, and it is a exact differential. So it is, write down, it is an exact differential, that is product of a small p into dq, d a small q, minus product of capital P multiplied by d a small q, that is a differential of position coordinate capital Q in the new coordinate system, and it is equal to 1 by 2 d of P into Q, that is differential of product of P and Q is P dq plus Q dp, and we can write it as d of under bracket 1 by 2 PQ, and it is an exact differential. So the given function, that is the given functions P is equal to 1 by 2 under bracket P square plus Q square, and the given functions or given transformation P is equal to 1 by 2 under bracket P plus P square plus Q square, small p square plus Q square, and capital Q is equal to tan inverse a small p upon a small q is canonical. Now it is proved that the given transformation capital P equals to 1 by 2 under bracket a small p square plus a small q square, and capital Q is equal to tan inverse q upon a small q is canonical, because product of a small p into d a small q minus capital P into d capital Q is a differential of 1 by 2 PQ, that is an exact differential. P dq, P product of P and Q का differential P into dq plus Q into a small p into dq plus a small q into d a small p होगा, जो कि एक परफेक्ट डिफरेंशियल है. सो इट इज d of half pq, so it is an exact differential. So the given transformation in the first example or in the first problem based on canonical transformation is canonical. Now we have to solve the second example of the given canonical transformation, which is to show that the transformation capital Q equals to log under bracket 1 by a small q sin a small p bracket closed, and capital P equals to a small q into cot a small p is canonical. Again we have to show that the product of a small p multiplied by dq d a small q minus capital P multiplied by d a small d capital Q, that is differential of capital Q, must be an exact differential. So we have a small p multiplied by dq, that is d a small q, minus capital P multiplied by d capital Q, that is differential of capital Q. Capital Q is the position in the new coordinate system. Capital P is the momentum in the new coordinate system. A small p is the momentum in the old coordinate system, and a small q is the momentum, a small q is the position in the old coordinate system. So product of a small p into d a small q minus capital P multiplied by d capital Q, we can write it as p into a small p into dq minus, in place of capital Q, in place of capital P, we can write a small q into cot p, which is given in the transformation. So second term is minus capital P into dq, and in place of capital P we have a small q into cot p, cot a small p multiplied by differential of capital Q, and in place of capital Q we can write d of log under bracket 1 by a small q into sin a small p bracket closed. Now we have a small p into dq minus capital P into d capital Q equals to, we can write p first term is a small p multiplied by d a small q minus q, second term is q a small q cot p multiplied by differential of log under bracket 1 by a small q into sin p is 1 by q into sin p. We know that differential of dc of log x is equal to 1 by x. So d of log under bracket 1 by q, a small q sin p is 1 upon sin p upon q, that is 1 upon 1 by q into sin p. And now we have again differential of the function inside the bracket, which is 1 by q into sin p, that is d of sin p upon sin a small p upon a small q. Now we have p a small p into dq minus a small q multiplied by a small q, that is 1 by q a small q in the that is the term 1 by a small q in the denominator, that is 1 upon 1 by a small q into sin p. So 1 by a small q, that is q, the term q will multiply in the numerator. So it is q into q, that is a small q into a small q, that is q square, a small q square cot p multiplied by 1 by sin p in the denominator only. Sin p and the term sin p will now the only term in the denominator outside the bracket. So it is 1 by sin p multiplied by now differential of sin p upon q, that is the term inside the bracket. So using it is again in the quotient form, that is differential of two functions, that is in the fraction, that is in the form of numerator by denominator. So using the formula d of a small u upon v, where a small u is the function present in the numerator and a small v is the function, is the second function present in the denominator. We have d of a small u upon v equals to v into du, that is denominator multiplied by dc of numerator minus numerator is constant, that is u multiplied by dc of denominator, that is dv, that is dc of denominator is v, a small v say, so it is dv upon denominator square, that is v square. So we have in this term, that is term inside the bracket, that is differentiation of sin p upon q. Sin p is present in the numerator and q in the denominator. So it is denominator, that is a small q is constant, taking first denominator q as constant using the formula. So q is constant and d of sin p, that is the differential coefficient of numerator is sin p is cos p. So it is cos p and d of p, that is dp. Differential of p is now dp. It is exact differentiation, and minus second term is negative. So minus now sin p is constant and second, that is numerator is constant using the formula, and dc of denominator is a small q. So it is dq, sin p into dq second term. So we have differentiation of sin p, sin a small p by q is q denominator constant multiplied by dc of numerator, that is dc of sin p is cos p into dp minus sin p, numerator is constant in the second term, and differentiation of denominator, that is dq upon denominator square, that is q square. Now bracket is closed and q square in the denominator inside the bracket term, and numerator in the numerator also q square is present. So q square in the denominator inside the bracket, and in the numerator q square will cancel out. So we will left with it is a small p into dq minus cot p multiplied by, Now it is a small q inside the bracket. It is a small q. The first term is a small q cos p into dp divided by sin p. Now taking sin p inside the denominator, we can write q into cos p dp upon sin p minus second term is minus sin p multiplied by dq divided by sin p. Outside the bracket, the term present in the denominator sin p. So multiplying 1 by sin p by both terms inside the bracket, it is first term is inside the bracket is q cos p dp upon sin p minus second term is sin p dq upon multiplied by 1 by sin p. So it is sin p dq upon sin p. In the second term, inside the bracket, sin p in the numerator and denominator will cancel out. So we will now we can write p a small p into dq minus cot p, and inside the bracket it is q upon cos p upon sin p, that is cot p. So it is a small q cot p into dp minus second term is only dq. Now second term is d a small q, because sin p in the numerator and denominator are cancel out. So in the second term inside the bracket it is only dq, d a small q. Now we have now we have p a small p dq minus q a small q into cot p. आफ्टर रिमूविंग द ब्रैकेट हटाने पर कॉट पी से बोथ टर्म्स में ब्रैकेट के अंदर जो टर्म्स है उसमें मल्टीप्लाई करना होगा. सो इट इज q इंटू कॉट पी डी पी मल्टीप्लाइड बाई कॉट पी. सो इट इज माइनस q कॉट पी इंटू कॉट पी कॉट स्क्वायर पी इंटू डी स्मॉल पी माइनस कॉट पी मल्टीप्लाइड बाई माइनस डी क्यू. इट इज प्लस कॉट पी इंटू डी क्यू, कॉट पी इंटू डी क्यू. एंड नाउ we can write second term minus q cot square p into dp as q into minus cot square p dp. We can write it as under bracket using the formula cosec square theta minus cot square theta is equal to 1. So in place of minus cot square p we can write 1 minus cosec square p. So it is a small q. Second term is q a small q multiplied by a small q multiplied by 1 minus cosec square p dp. In place of minus cot square p we have written under bracket 1 minus cosec square p into dp. And first term is p dq and the third term is cot p dq. In both terms dq is common, so it is we can write it as plus p under a small under bracket a small p plus cot a small p bracket closed multiplied by dq. Taking dq out of the bracket because dq is common in both terms, in the first term and in the last term. That is first term is p dq and the last term is plus cot p dq. So it is under bracket a small p plus cot p into dq. And the second term is q into 1 minus cosec square p into dp. In place of cot square p dp we have written 1 minus cosec square p into dp using the formula. So the second term is a small q multiplied by under bracket 1 minus cosec square p a small p dp. And first term and third term taking together it is under bracket p plus cot p bracket closed multiplied by dq. Dq is common in both terms. Now it is the differential of that is differential coefficient of the product of q multiplied by p plus cot p. which is an exact differential. Now finally we can write P we have taken initially a small p into dq minus capital P multiplied by dq d capital P multiplied by d differential of capital Q. So it is a small p multiplied by d small q minus capital P multiplied by d capital Q equals to d of product of q multiplied by p plus cot p. अगर स्मॉल q एंड सेकेंड टर्म स्मॉल p प्लस कॉट p जो कि ब्रैकेट के अंदर यहाँ रखा गया है, इसका डिफ्रेंसिएशन किया जाए दोनों बोथ फंक्शंस के प्रोडक्ट का, तो रिजल्ट उसका एबव टर्म होगा, दैट इज q मल्टीप्लाइड बाई अंडर ब्रैकेट 1 माइनस कॉसेक स्क्वायर स्मॉल p डी स्मॉल p ब्रैकेट क्लोज्ड प्लस अंडर ब्रैकेट p प्लस कॉट p स्मॉल p प्लस कॉट स्मॉल p ब्रैकेट क्लोज्ड मल्टीप्लाइड बाई dq. सो स्मॉल p इंटू dq माइनस कैपिटल P इंटू d कैपिटल Q d capital Q is the differential of the product of two functions a small q multiplied by under bracket p plus cot p bracket closed, and it is a perfect differential. So write down it is a perfect differential. So the given transformation, that is given transformation capital Q equals to log under bracket a small 1 by a small q sin p and capital P equals to a small q multiplied by cot p is canonical. So this is the result. Hence the given transformation capital Q equals to log under bracket 1 by q sin capital P and capital P equals to a small q cot a small p is canonical. Now this video is completed. Thanks all of you for watching my YouTube channel Physics Quantum Classes. In coming videos we will solve some other examples or problems based on canonical transformation.